In last class, we studied the pressure exerted by the solids. What is the formula for pressure exerted by solids? Anybody can tell? Pressure exerted by solids. All of you? So pressure P is equals to thrust by area, or we can say, also we can call it as a what? All of you? It is
Force by
force by
area.
area, or we can say force is equals to what actually? Weight of the object. We can say weight by area. See, today it will be very interesting, and we are going to make the formula also for liquid pressure. You can calculate anything. So now you can notice it here.
Yesterday we have found it, sir. Oh,
Yes, Mari. That is for liquid pressure. No measurement today. Do you understand how you can measure it? That is what. Okay. So now we all knows that the SI unit of pressure is what, everybody? Pascal. So Pascal is equals to what? Newton per square meter. Clear? Now next, in last yesterday's class, I taught you pressure exerted by fluids. What is the examples of fluids, everybody? That is what we used to call it as a liquids. Another one is what? Gases. So the pressure exerted by the liquids, what is the formula, all of you? Pressure exerted by the liquids, we used to call it as a rho G H. So what do you mean by rho, everybody? Rho means what? Density of the liquid or fluid into G means what?
Acceleration due to gravity.
Due to gravity, acceleration due to gravity. And the next one is what? H means what, everybody? Height of the liquid column or fluid column. Height of the fluid column. So that is what we used to call it as liquid pressure. So pressure exerted by liquid is rho GH. Now, today's class we are going to discuss what is the device we are using to measure the liquid pressure or gaseous pressure, and how it will be using and how we can calculate it. So the device which we are using to calculate liquid pressure is manometer. Even in class 8 you might be studied. Atmospheric pressure is measured. Atmospheric pressure is measured with the what? Anybody? Device. Atmospheric pressure is measured with the barometer, and liquid pressure is measured with the, everybody, what is that? Manometer. Okay.
Substance.
Yes. So now let us discuss to measure the pressure of a liquid. So how to measure the liquid pressure? 8th class you might be studied the experiment also. Am I right, Mr. Mari? How to measure the liquid pressure? So of course, just I will show you that. After that, I will make it. So it is actually U2 manometer. We used to call it as a U2 manometer. Just so basically we used to call it as a U2 manometer, and then I will teach you from this. Just it is a 8th class one. So if you remember how to measure it, then I will say you the mathematical formula how to calculate it. Okay. So just it is for to make you knowledge revise. That's all. Nothing else is there. 8th class what you studied, the same thing. But this will be like, it will give you the scientific temper to you, like how the every concept what you studied in 8th class, 7th class, now there will be a formula formation. There will be a mathematical approach. That is the reason to make you that awareness only. This I'm just showing you. So please observe.
In this media, you will learn about an experiment to measure the unknown pressure value using U-tube manometer. U-tube manometer consists of a glass tube bent to a U shape. Initially, the U-tube is filled with a manometric fluid such that the level of the fluid is same in both the...
See that. So we are filling with a manometric fluid. Basically, we are having water manometer or mercury manometer, many different types of manometers we have. So we have to fill this liquid so that both the columns it will attain the what height? Everybody? Both the columns it will attain the what height? Same height. Do you understand, all of you? So that is only we used to call it as a U2 manometer. Now you can see what else next. Okay. So notice it.
limbs. The manometric fluid in the U-tube can be oil, water or mercury whose density should be known.
You can use anything. If it is oil, manometer, water manometer, or whatever it is.
There are two limbs in the manometer, L1 and L2. A graduated scale is fixed between the two limbs. When both the limbs are exposed to same pressure medium, the fluid level in the two limbs will be equal.
Now, my question to you. Is it both the limbs are experiencing the same atmospheric pressure or not? Yes, Mari? Sanjay? Both are experiencing the same atmospheric pressure or not? That is what is my question. Am I right or wrong? Please respond.
Yes, sir.
Yes. That is why the liquid column is what? That is why the liquid column is what? Same height. Are you
Stable.
clear, everyone? Same height. That is the most important thing you have to observe it. Now you can notice it. Everybody.
Now let us measure the pressure of air trapped inside the tube.
We
The
can use
limb-
this one to measure the liquid pressure or gaseous pressure also you can use it. Nothing wrong. We can use a device, a manometer used to measure the pressure of a gas or pressure of a liquid. But pressure of a atmosphere, basically we'll use it, call it as a barometer. So barometer, manometer, all the things, simply we can use it. Even barometers, different varieties of barometers are there. 14-inch barometer is there. Aneroid barometer is there. Simple barometer is there. But there is a different varieties of things. So that is what, if you are going to keep on studying higher classes, you are going to get different things. So that is what you have to take it. So now this manometer, we are going to measure the pressure of the atmosphere also, we can measure it. The pressure of any liquid also, we can measure it. Okay, that's what you have to remember it.
L1 is open to atmospheric pressure and the limb L2 is connected with a rubber tube. The rubber tube consists of a clip to make it airtight after the air is blown through it.
Now you can see, he is measuring the pressure of a gas. Not only that, liquid also you can measure. Nothing, whatever it is saying. Now he is connected one limb to a pipe and he is blowing the air. Now you see, this side pressure increases or decreases, everybody? Pressure increases so that the liquid will be pushed up. But how much pressure, how to calculate it? Just have a glance and then we are going to make it. Okay, do it.
The
We need to
pressure of the
subtract
air
it,
in L2 is now greater than the pressure in L1. Now the fluid in the U-tube is displaced to a new position. The difference between the two readings will give height of the fluid level in the tube. The formula for calculating the pressure of air trapped inside the tube is given by P equals rho GH. On substituting the corresponding
We already got the rho GH. Am I right or wrong? Everybody? Yes, please respond.
Yes, sir.
Love you. That is what. Okay. Great.
values in the above formula, we get the pressure value. Let us now measure the pressure of the water column.
Okay. This
The
I will.
limb L2
So anyhow, just this is for idea. I am just showing you how the manometer works. I hope you all know class 8 you studied. And again, class 9th, we are going to derive the formula now. So just you have to remember. Do you all have an idea now? What do you remember? 8th, 9th class, what you studied? 8th class, what you studied? Everybody? Yes, please. Respond, guys. That's what it is. Okay. So now we are going to see how we are going to measure this U-tube manometer. What is the pressure? High pressure, low pressure and all. In our atmosphere, you can see, we can notice sometimes high pressure, sometimes low pressure and all. So that is only we are going to make it now. And we are going to derive the formula also. So this is the three pictures which will speak about, you can see, all of you. The tube contains a liquid in both the arms. That is what is the P1, basically a picture, normal pressure. If it is a normal pressure, all of you observe, atmosphere, when both the arms of the manometer are exposed to the air, the level of liquid in both the arms is equal. Will you all agree with me, everybody? The level of fluid in the both the arms is equal. Am I right? Please respond, guys, all of you. So,
Yes.
as the pressure at the surface of the liquid in both the arms are equal, to to the which pressure? Atmospheric pressure. Please remember, the pressure at the surface of the liquid in both the arms, which is equals to the atmospheric pressure. So I am taking atmospheric pressure as P0. Please note it, everybody. Atmospheric pressure, I am taking as a what? Atmospheric pressure, I am taking as a what, everybody? P0. That is the symbol for here I am taking. So when the pressure inside this tube, liquid pressure is equals to atmospheric pressure. So both the columns, liquid is in the same height. That is indicating that normal pressure. Normal pressure. Now, one of the arm of the tube, let me say left arm, is connected to a container consisting of a gas. So you can take anything. So left arm consisting of a gas. If you take, okay. Now if you see, the pressure of a gas enclosed in the container, that's what A is here. You can see, if you notice it here, if I blow the air like that video, how it is. So one side he is keep on blowing the air. Here it is connected. Your choice, whatever it is. So what is happening? Definitely the pressure is one side. The liquid is displacing into the some other side. If I put here, see this pressure is greater, then the liquid is rising to like this. Now this pressure is greater, the pressure is rising to this side. So it is indicating, see, if this side liquid is indicating, they are mentioning something low pressure, and this side the liquid is displacing, it is high pressure. I will explain you. So all of you observe very carefully. The tube contains the liquid.
Say it again.
Yes, Mark. Listen very carefully. First thing, both the arms of the manometer are exposed to the air. So the level of the liquid in the both the arms is what? Equal or not equal? Everybody? Equal or not equal? Yes, please. It is equal. Clear? Now, so here in this case, what is happening? The pressure at the surface of the liquid, that is what P. Pressure at the surface of the liquid P, which is equals to the atmospheric pressure P0. That is how to remember. Now, if you have noticed it, all of you, one of the arm of the tube, let me take it as a left arm. You can take it as this is our left arm and this is our right arm. Okay. So you can take left limb or right limb. So I am taking a left arm and right arm. Okay. So now what happened? You observe very carefully. It is connected to a container which is consisting of gas. So now when the level of the liquid in both the arms is equal, if it is shown in the first one, then the pressure is same. But if you see, the pressure of the gas enclosed in the container, that is what level A. Level A is basically equals to the atmospheric pressure. But when the level of the liquid in the left arm is above the level of the liquid in the right arm, you can notice it. Above the level of the liquid in the right arm, then you can see the pressure of the gas in the container is less than the atmospheric pressure. If it is more than that, then the pressure is greater. The gas which is container, the cylinder, is more. If this pressure is less, then atmospheric pressure is greater than the gas pressure. That is what it is saying. All of you understanding? So always in both the cases, once again I'm saying, you observe very carefully. The C point is our basic level. The C point in the left arm to the right arm is actually the equal point. If the pressure in the gas cylinder is less than the atmospheric pressure, then the liquid will rises this side. Purima Mari, what I'm saying? So that is what indicating low pressure. The pressure of the gas or a liquid is greater than the atmospheric pressure, then the liquid will rises into right arm. Okay, ma, girls, Agalya, understand now what I'm saying? So, if you want to calculate a liquid pressure or a gaseous pressure given gas, First, I have to take a U2 manometer. I have to fill some liquid. Both arms equal pressure. Both arms equal pressure. Now, I connected to a cylinder. I connected to a cylinder. Please observe very carefully. Now, the cylinder pressure is equals to the pressure of a cylinder is P. The cylinder pressure is equals to the atmospheric pressure. So both the columns liquid will be in same height or different height. That is what my first question. Everybody? The pressure of a gas which is present in the cylinder, both the pressure is equals to the atmospheric pressure. So liquid will be in a same height or different height. That is what I'm asking. Everybody? Same height. Now, the same left arm will connected to a cylinder, is connected to a cylinder whose pressure is low. Whose pressure is low actually. Low pressure than atmospheric pressure. So what will happen? Atmospheric pressure is more. Atmospheric pressure is greater than the pressure of a gas cylinder. So liquid will be pushed and it will be raised in this way. Am I right or wrong? Will you all agree with me? Please respond. That is indicating that it is low pressure. What is that? Everybody? Please respond. It is low pressure. Next, if I connected to this one to a cylinder and the cylinder gas or a liquid, whatever it is, this pressure is more, means the pressure of a liquid or a gas is greater than the atmospheric pressure, then the liquid will be up rising into right arm. That is what it is indicating, that high pressure. Have you all understand or not? Kavya, Sangamitrai, Agalya, that is what you have to remember. Any
Sir,
problem?
is this container filled of any gases or
Any
fluids?
gas or any liquid, Mari, any gas or any liquid. If the gas pressure is less, atmospheric pressure is more, then it will be rises to that. That is indicating that it is low pressure. If you notice that this side we are fixing. Why, sir? How you can say it is atmospheric pressure? Because it is not connected to anything. It is directly exposed to atmosphere. Clear, Mari? Lingesh?
Yes.
Exposed to atmosphere. So always in this arm or in this limb, always what pressure? Anybody? Always what pressure? In this right arm. Right arm, always it is what pressure? Atmospheric pressure. Right arm, always what pressure? Atmospheric pressure. Left arm, if it is equal, then the gas pressure or liquid pressure is also equals to atmospheric pressure. Okay. Now, second picture, what is happening? I connected to a gas cylinder whose pressure is lower than the atmosphere, so that the liquid is rising into this side. Do you understand, everybody? So it is indicating that the given liquid or a given gas is having a low pressure than the atmospheric pressure. So atmospheric pressure will push this liquid so that the liquid will rises to this column. Now I connected to the left arm to the cylinder whose pressure is greater than the atmospheric pressure. That is what? High pressure. So that the fluid is displacing into this side. That's what it is. Nothing else is there. That is indicating high pressure. Purima, everybody understanding, guys?
Yes, sir.
Yes. So please
Yes, sir.
respond. Not okay, clear? Now, let me take the first one. All of you observe. When pressure at C point, let me take the pressure at C. What is the meaning of C? I said C is considered as a what? Consider C is an equal point, equal level point in the left arm as well as right arm. Okay, let it. C considering an equal level point in the left arm, to level B in the right arm. Level B in the right arm. Okay. So that is what you have to remember. So now you can see how it will happen. So all of you observe very carefully here. Just I'm erasing so that you can notice it. Now we are going to make it, all of you observe. Here if you notice it, if this point is indicating what, guys? Both AB are at the same level. What does it mean indicating? It is a normal pressure or high pressure or low pressure? Everybody? Normal pressure or high pressure or low pressure? All of you. Please respond. Yes, please.
Normal pressure.
Normal pressure. Clear, everybody? Now, when the pressure of the gas is more, than the atmospheric pressure, then you can see the left arm of the manometer is pushed down, and the pressure of the right arm is, the liquid is rising in the right arm. If the atmospheric pressure is greater than the liquid pressure, then the liquid is pushed down in the right arm and it is rising in the which arm? Everybody? It is rising in the left arm. So now, if it is the normal pressure, then you can remember the pressure of the liquid is equals to rho GH. That's all, we can easily find it. If it is a normal pressure, then atmospheric pressure is equals to also P, which is equals to rho GH. Now, if it is the low pressure, means the pressure at point C, which is equals to, basically if it is the same pressure, which is equals to point B, but here it is having a low pressure than the gas. So what is the pressure? Let us discuss now. So when you can see the H is the height difference in the levels of the liquid in the both the arms, and density of the liquid, and the G is the acceleration due to gravity. Let me take the density of the liquid is rho, and G is the acceleration due to gravity. Now, if you notice it here, all of you observe, if you want to calculate the pressure of a gas or pressure of a liquid, any cases, either it is a low pressure or high pressure, all of you remember, we will take the pressure of a gas is considered as a P, and pressure of atmosphere is P0. And we all knows that what is the liquid pressure or gaseous pressure formula? Liquid or gaseous pressure formula? Everybody? Liquid pressure is equals to rho GH. So, if you want to calculate the pressure of any kind of a gas or any kind of a liquid, please note it. The pressure of a gas or a liquid is equals to P0, atmospheric pressure minus height of the liquid rises. Either high pressure or low pressure, doesn't matter. Height of the liquid rises into density of the liquid into acceleration due to gravity. This is the formula for calculating pressure of any kind of gas with the help of U2 manometer. Either it is a low pressure or high pressure, no problem. So pressure of a given liquid or a given gas, you can see, we can calculate it. P is equals to pressure of a given gas or liquid is equal.
So then for both liquid
Yes.
and gaseous pressure, the formula
everything.
is rho GH.
Atmospheric pressure minus height of the liquid which is displacing into density of the liquid into acceleration due to gravity. That's all it is. Now, for example, if you want to find the atmospheric pressure, can you tell me what is the formula modified? Atmospheric pressure is equals to this minus rho GH will come this side. What will become, guys? Everybody? So atmospheric pressure is equals to, respond.
Atmospheric pressure in the sense gaseous pressure.
Yeah, gaseous pressure plus, yes please, H into rho into G. That is the formula for calculating atmospheric pressure of any kind of thing. Either it is a low pressure or high pressure. So remember, basically, this is the formula. The pressure of a gas is more than the atmospheric pressure. Then this is the formula we can use it. So pressure of atmospheric pressure is equals to pressure of a liquid plus rho GH. If the pressure, remember, if the pressure of a gas is more than the atmospheric pressure, then the liquid in the left arm will be rises. The pressure in the gas is less than the atmospheric pressure, then you can notice it. We will see it is the Here atmospheric pressure is greater than the liquid pressure, and here liquid pressure is greater than the atmospheric pressure. So that is how the liquid will rises. So we can say we can
Sir,
calculate the low pressure or high pressure. Yes, tell me.
sir, one doubt, sir.
Yeah,
Air pressure plus liquid pressure is equal to atmospheric pressure, sir.
atmospheric pressure.
Okay, sir. Sir, if we want to find atmospheric pressure, means what we can do, sir?
Atmospheric pressure
Sir,
basically
no,
will.
sir. We want to find air pressure. Air pressure.
Now air pressure, that's what, if you want to calculate air pressure, just we can like we can rise in mercury, we'll use a barometers. Generally we'll use a barometer.
Formula, sir,
Yeah,
formula.
there is a rise in mercury column. If I place the mercury at the normal room temperature or at a sea level, the mercury will start rising up to a 75 mm. 75 mm. You understand? Sorry, 75 centimeters it will rises in a mercury when it is placed in the normal thing. So that 75 centimeters means 750 mm rise of mercury is only equals to atmospheric pressure. That is what 180. You understand?
Yes, sir. Then what is the formula to find air pressure, sir?
Air pressure, there is no formula. That's what we can say. The air pressure, if you want to find, that we will use a barometers. Different varieties of barometers we have. So we will conduct that experiment. Then rise of mercury is considered as atmospheric pressure or air pressure. You understand, Mari?
Yes, sir. Yes, sir.
Yeah. At sea level, see, basically at sea level we have taken. So if you take the sea level, the atmospheric pressure basically will get a rise of mercury. So that is only directly we will take it. So there is no particular formula for calculating air pressure. Understand? Yeah. Now Mr. Lingesh is having a question. Sir, what is the role of gravity in a function of manometer? Because it is the height of the liquid, correct, Lingesh? So that definitely there will be a force of the acceleration due to gravity is exerting on the downwards. Understand? Rise in liquid. Understand, Lingesh?
Yes, sir.
Yeah. So wherever any object is going above from the ground, then definitely there is a pull will be there. Pulling force will be there. What is that force we used to say? Acceleration due to gravity. Do you understand?
Yes, sir.
Yeah. So if you want to calculate the pressure of a gas, what is the formula, everybody? Pressure of a gas is equals to atmospheric pressure minus rho GH. So you can calculate this formula, we can use it. So whenever the levels of the liquids in both the arms, do you understand, everybody? If you want to calculate a liquid pressure or a gaseous pressure by using a manometer, you can use, this is the formula for calculating. So the pressure of a gas or a liquid is equals to atmospheric pressure minus rho into G into H. Okay, that is the formula. So if you remember this, then as Mr. Mari asked, what is atmospheric pressure graph? I will show you that. So is there any doubt, you can ask me. I will understand how to calculate atmospheric pressure, the pressure of a gas. Yes, please.
Yes, sir.
Yeah. So this is what you have to remember it. Now you can see, I will show you that you all can see how it will be the graph when you expose the atmospheric pressure, how it will be measured if the temperature changes, that and all. So if you see that, all of you, the graph will be like if I conduct the experiment of a barometer for observing the atmospheric pressure, then the graph will be similar to like this. So this is the graph which will gives you the idea of atmospheric pressure in centimeter rise of Hg. As I said, so we can take the barometer, simple barometer, for example, if I take, which is containing the mercury. So if I take the mercury and if I put it in the normal sea level with the inverted tube, this is the simple barometer, then the mercury is rising up to a centimeters of, if it is the normal pressure, the mercury is rising up to 76 centimeter, which is equals to 760 mm. 760 mm, the mercury is rising in the column. That is only we used to consider as, what we used to consider? normal atmospheric pressure. That is what.
Sir, is it
what
completely closed or is there any space between
No,
it, sir?
normal. It is
Mercury,
completely
water.
open to the atmosphere, Mari. Atmosphere, it is exposed to the atmosphere. Do you understand it? That is what it is rising.
Sir, with the liquid and the mercury.
Yes. Liquid. This is liquid, Mari. Liquid it is.
Sir, is it
That is what
the
mercury.
mercury is
Mercury.
closed or it is
Yeah.
opened, sir?
Which one? It is open, Mari. Only tube, inverted tube is kept. Purima,
Yes,
it is
sir.
exposed to atmosphere because atmospheric pressure has to experience it, correct? Clear?
Yes.
Yeah. So then mercury is rising to the what? Everybody? 76 centimeters. Means which is equals to 1 atm. That is why we will say atmospheric pressure is equals to, all of you remember, 760 mmHg. What do you mean by mmHg? Anybody? Another unit of pressure. Another unit of pressure. What do you mean by mmHg? Rise of mercury. Rise of mercury. Understanding? Is only call it as mmHg. mmHg means millimeter rise of mercury. Millimeter rise of mercury. So mercury means, what is the symbol of mercury? Everybody, Hg. Okay. So if it is a normal sea level, if you are at a normal sea level, mercury rising up to what, guys? Everyone, 76 centimeters. Okay. Now, if you are keep on going up, I already taught you, if you are going above from the ground, your atmospheric pressure decreases or increases? Anybody can tell? Atmospheric pressure decreases or increases? Everybody. If you are keep on going up, guys, if you climbing the mountains, atmospheric pressure decreases or increases? Decreases. Do you understand? So atmospheric pressure is decreasing when you are keep on going up. This is what is indicating. You can see, if you go 3 kilometers above from the ground, atmospheric pressure is reduces. If I go 6 kilometers, you can see 9 kilometers, 12 kilometers, 15 kilometers, 18 kilometers, 20, 21, 24, 27, 30. So height from the sea level. If I am keep on going, you can see there is a drastic downfall of atmospheric pressure. So when I reaches to the almost 15 kilometer, you can see atmospheric pressure almost 19 mmHg. So that is the reason those who are climbing mountains and all, they should maintain always oxygen cylinder, because suffocation it will be. So it will create low pressure. Pressure is keep on decreases when you keep on climbing. So this is the atmospheric pressure in centimeter of Hg. So 76 centimeter it will rise as mercury when it is at normal sea level. If you are at the surface, the rise of mercury will be 76 centimeter. I hope you all understand. Everybody clear? Understand, Ra? Yes, please. All of you. So that is why 1 atm is equals to how many pascals? I said 1 atm is equals to 10 power 5 pascals. Am I right? Exactly. If you want 325 pascals, or we can say approximately 1 lakh pascals is equals to 1 atmospheric pressure, which is equals to 760 mmHg, millimeter rise of mercury. Understand, Sam? Shivani? These all are the units of pressure. Units of pressure. Please note it. Clear, guys? All of you? Please respond, guys. Yeah. So now, if you understand this, then as I said, at a given liquid, if you take anything, so the pressure of a liquid depends on two things. Can you tell me? Three things. What is that? Can you tell me, everybody? Yes, please. Height of the liquid. Next one. Anybody?
Density of
Density of the liquid. And you can see at a given depth, as I said, if you take any kind of liquid, okay, so at a given depth, the pressure is distributed uniformly. The pressure, if I take inside a column, at a given depth, if I take it and I put the hole here and hole here and hole here, all the directions, the liquid will come to the same speed. Means The pressure at a given height of the liquid is uniformly distributed in all the directions. So that is only call it as a Pascal's law. So please remember, inside a liquid, the pressure is transmitted equally without any change in all the directions to every other point in the liquid. That is only we used to call it as a what law? What we used to call, all of you? Pascal's law. If you open in our book NCERT, after the liquid pressure, that last paragraph you will be having this point. The pressure is undiminished, or it is distributed equally in all the directions. That is what we used to call it as a what law? Everybody wish to say? Please respond. Pascal's law. Or also we used to call it as the law of transmission of fluid pressure. Law of transmission of fluid pressure. Write it. Law of transmission of fluid pressure. Law of transmission of fluid pressure. Okay. So this is what? Write the definition of Pascal's law. Pascal's law. Right. The pressure at any point inside a liquid, the pressure at any point inside a liquid, the pressure at any point inside a liquid at rest, comma, is transmitted equally and without any change in all directions to every other point in the liquid is known as Pascal's law. Clear, everybody? So what is this also called as? The law of transmission of fluid pressure, also known as law of transmission of fluid pressure. Law of transmission of fluid pressure. Law of transmission of fluid pressure. Clear, everyone? All of you?
Yes, sir.
Yeah.